Hey guys, how is it going? I hope everything is good. In this lecture, we'll be solving fundamental problem number 10 of chapter 2, force and vectors. This problem states that if the resultant force acting on the aggregate is to be 750 Newton. So we know the value of the resultant force, its magnitude, and it is directed along the positive x-axis. So we also know its direction. The resultant force will be acting on the positive x-axis. So its magnitude is 750 Newton. So I represented the resultant force as Fr. So it is acting on the positive x-axis. What we need to determine, the value of the resultant, this force and its direction. So we already know the value of the resultant force. We need to find the value of this F force. So it means we have this resultant force. It has three components, this, and this force. So we know the value of the resultant force and two of its component. We need to find one of its component magnitude and its direction from this x-axis anti-clockwise. So two things we need. This is a little bit different from the previous lecture. In previous lecture, we found the value of the resultant force. But in this lecture, we know the value of the resultant force. We need to find one of its component. So I will be naming each force as F1, F2. So this will be, I'm considering this force as F1, this known force as F2, and we already know the name of this force is given in question. We do not want to change. So I will be keeping it as F, and this is Fr. So I will be resolving each force along its x and y component. So now I will be resolving this F1 force into its rectangular component. So this will be the F1 Fy component, and from the origin this will be the Fx component. So the direction of the Fx component will be on the right, and the direction of the Fy component will be downward. So this will be the F1x, this will be the F1y. So now I will be applying basic trigonometry, cos theta and sin theta to find the value of the F1x and F1y. So for this F1y, for F1x, I will be applying cos theta formula, which is the F1 times of cos theta. So I will be putting the value of the F1 force, which is 600 into cos of theta. So the value of theta is 45 degrees. So instead of theta, I will be putting 45 degrees. So the value of F1x will be equal to 424.3 Newton. So its direction is on the right side, so it will be positive. Now I'll be finding the value of F1y, which will be equal to F1 times of sine theta in this case. Why sine theta? Because it is now I am taking this side. So this side is considered as a perpendicular. So sine theta is perpendicular or hypotenuse. So I just applying this sine theta. So putting the value of F1 force and theta. So the F1 force value is 600 and theta value is 45. Now what will be the sign? So this F1y component is directing downward. So this sign will be negative. So the F1y value will be equal to minus 424.3 Newton. This will be the horizontal and vertical component of this F1 force. So I will be constructing large triangle and small triangle is already we have in the question. So for this F2 force, the y component will be in this manner, and the x component will be on the right side. So this will be the F2x, this will be the F2y. For F2 force, the x and y component will be in this manner. So if you can see this this is one triangle, and inside we have this small triangle. So we will be applying similar triangle technique for the horizontal and vertical component of the F2 force. So for F2x, I will be using the similar triangle technique, which says that the base of large triangle divided by the base of this is base of large triangle divided by base of small triangle, which is 5. It will be equal to the hypotenuse of large triangle, which is F2, which is equal to 352 divided by the hypotenuse of small triangle, which is 13. So now I will be finding the value of F2x. So I will be shifting this side to the other side. So after calculation, I will get the value of this F2x will be equal to 125 Newton. Now I will be finding the vertical component of this F2 force. So for this, I will also apply similar triangle technique. Now I'll be considering the perpendicular of large triangle, which is F2y divided by the perpendicular of small triangle, which is 12, will be equal to the hypotenuse of large triangle, which is 325, divided by the hypotenuse of small triangle, which is 13. Now I need value of the F2 force. I will be shifting this 12 to the other side, so it will multiply. So after calculation, I will get the value of the F2y force, which will be equal to 300 Newton. Now for this, both x and y value will be positive because the x component is acting on the right side and the y component is acting upward. So both value will be positive. So I will be writing this the F2x and the F2y, which is the horizontal and vertical component of this 2 force here. So because I need this value for future calculation, so we found the value of the horizontal and vertical component of this F2 force. Now I will be finding the value of this FRX horizontal and vertical component. Now I need to find the value of the horizontal and vertical component of this FR force, means the resultant force. So for this, you can see that this force is directly acting along the x-axis, directly acting along the x-axis. So it means that it doesn't have any y component. Only the FRX, which will be equal to FRX, means the horizontal component of the resultant force, which is directly equal to the FR, and its value is 750 Newton. So what will be the vertical component of the resultant force, means FRY. So it will be equal to 0 because there is no y component for this FR. So the FRY will be equal to 0. Now for this, what will be the x and y component? Like for this F1 force, the x component will be acting on this x-axis and the y component will be acting somewhere here. So I need to find the Fy and Fx. So for this, what I'll be doing, I will be applying the summation of the resultant force and then horizontal resultant force and summation of the vertical resultant force. So from there, I will get the value of the Fx and Fy respectively. So from this side, I mentioned all the information as I calculated, and we need to find the value of the Fx and Fy, which is the component of this unknown force, and the x component is acting on the right, and the y component is acting on the upward, on the y-axis upward. So we need to find the value of the Fx and Fy. So for this, I will be applying the summation of the horizontal force and summation of the vertical force. So Frx means the resultant of horizontal forces will be equal to F1x plus F2x, then plus this third force horizontal component Fx. So I will be putting the value of Frx, F1x, F2x. We will get the value of the Fx. So the Frx value means the resultant horizontal force value is 750. So I will be adding, putting instead of Frx 750, which will be equal to the F1x value is we already found, which is 424.3 plus F2x value. The F2x value is 125. So I will be plus Fx. So I will be shifting this 125 and this to the other side, and will be subtracting from the 750. We will get the value of the Fx. So after doing calculation, we will get the value of the Fx, which will be equal to 200.7 Newton. So we got the value of the Fx, means the horizontal component of this unknown force. Now similar we'll be doing for the Fy, like the Fry, the resultant vertical force will be equal to the F1y plus F2y plus Fy. So I will be putting the value of Fry, F1y, F2y. So the Fry value is here will be equal to 0. So there is no y component of the resultant force. Its value will be equal to 0. The F1 value is here I found it is minus 424.3 then the F2y value is 300 plus Fy. So now doing calculation, so the Fy value will be equal to 1, 2, 4.3 Newton. So this is the X and Y component of this unknown force. Now I will be applying the resultant force formula and we'll get the value of the result, this unknown force. So we have the X and Y component of the unknown force. We will be applying the magnitude formula, which will be equal to the F will be equal to the square root of Fx square plus Fy square. So putting the value of Fx and Fy will get the value of the force. So the Fx value is 200.7 its square plus 124.3 square. So putting the values in calculator, we'll get the value of the resultant force, which will be equal to 236.1 Newton. So this is the value of this unknown force. The magnitude of the unknown force we found, which is 236.1 Newton. Now what we need to find the value of the resultant force. We found the value of this F. Now we're finding theta. Now we'll be doing calculation for the angle direction. So for direction, we know the formula theta will be equal to the tan inverse of Fy divided by Fx. So we know the formula. So I will be putting the value of the Fy and Fx. The Fy value is 124.3 divided by 200.7. So after calculation, I will get the value of the theta, which will be 38.1 degree. So we found the value of the unknown third force and its direction measured from this axis anti-clockwise. So we found theta and this F value. So I hope you got the concept behind finding any component of the force if there is a term force and the other forces are given. So thanks to everyone.